Okay, we're back with section 3.8. Now we did the f of x equals e to the x equation already. Let's go ahead and look at f of x equals sine x, except for this time, that's all I'm going to do. I'm not going to do the cosine x because they're very similar, so you can do the cosine x on your own. And you also have some problems to look at in your homework assignment. So let's go back to writing what each one of these Taylor polynomials look like. So p sub 0 is going to be a polynomial of degree 0, and that is going to exist of f of a. Now in this case we are doing a Maclaurin series, so a is going to equal 0 in all of these cases. Let's write p sub 1 right here since we don't have a whole lot of room. P sub 1 is going to equal p sub 0, which was f of a, plus f prime of a times x. P sub 2 is going to equal all of p sub 1, which is f of a plus f prime of a times x plus f double prime of a over 2 factorial times x. And then p sub 3 is going to equal all of this plus f triple prime of a over 3 factorial times x, but whoops, this should have been x squared, and this is x cubed. Okay, so let's figure out what a Taylor polynomial for sine x is going to be. So first thing that we're going to do is we're going to start off by listing all of your derivatives. So first step, finding polynomial series is, or Taylor polynomial, is to figure out what all of your derivatives. Start off with f of x, and in this case we have f of x is equal to sine x. And let's go ahead and do all of our derivatives. So f prime of x is equal to cosine of x. F double prime of x is equal to negative sine x. And f triple prime of x is equal to negative cosine x. And then that looks like that's as far as we need to go. Okay, next step is going to be to list all of your f of a, f prime of a, all of that. So we're going to go back through this list. Now we're going to plug in our a value. In this case, a is equal to 0. So sine of 0 is equal to 0. F prime of 0, plug in 0 here, cosine of 0, which is equal to 1. Then f double prime of 0 is going to be 0, and f triple prime of 0 is going to be equal to negative 1. Then we need to know what our coefficient for each one of these series is going to be. So let's go ahead and list our coefficients also. So our coefficients, let's go ahead and include our the whole thing here, the f double prime of a over 2 factorial once we get down that far. So for just f of 0, or a 0 degree polynomial, our coefficient is going to be 0. Okay, so this value is right here. C sub 1 is going to just be 1. C sub 2 is going to be 0 over 2 factorial, which is really just 0. And then C sub 3 is going to equal negative 1 over 3 factorial. 3 factorial is going to be 3 times 2 times 1, which is 6. So that's going to make that negative 1/6. Okay, so now let's go ahead and look at what each one of those polynomials will be. So p sub 0 is going to equal just our coefficient, which is 0. So p sub 0 is 0. P sub 1 is equal to all of p sub 0, which is 0, plus our coefficient 1 times x to the first power. So simplifying all of that, we'll get just x. So p sub 2 is equal to p sub 1, which all simplified down to just x, plus our coefficient, 0, times x squared over 2 factorial, which since that's all multiplied by 0, it's going to just be x plus 0, which is x. And then p sub 3 is going to be equal to p sub 2, which was just x, plus our coefficient, which was negative 1/6. Oh, now let's go back to that. I didn't need to include that negative, or that 2 factorial, because it was already included. Not that it changed my answer, but we did that and include that in our coefficients back here. So we don't need to include it again. So the negative 1/6, that 3 factorial is included in my coefficient, and then times x cubed. So simplify that a bit, we get x minus 1/6 x cubed. So I went ahead and graphed this on Desmos so you can get an idea of how close we can really get with a Taylor polynomial and graphing the equation sine of x. So I'm going to switch over here to Desmos. Now you can see in Desmos that I have graphed these equations. So y equals sine x is in red, and then y equals 0, which was our p sub 0 polynomial. So Taylor polynomial with degree of 0 was just 0. You can see that blue line. That's obviously not very close. It's only correct for the point 0, and that's it. Then in green, we have y equals x. You can see we stay pretty close for a little while for that y equals x, at least to 0.3 and to negative 0.3. That y equals x is exact. Then we go on to our third degree polynomial, which is purple. And in that purple, you can see we are exact clear up to probably 1 even. From negative 1 to positive 1, we're almost exactly correct on that Taylor polynomial. So if we would just keep going and adding more and more terms to that, we would have an exact replica of what that sine function is. Okay, so let's go ahead and start looking at some of the examples that you're going to do for your homework assignment. On example number 1, we are interested in the first few Taylor polynomials for the function f of x equals 5e to the x plus 4e to the negative x centered at a equals 0. So really a Maclaurin series. To assist in the calculation of the Taylor linear function t sub 1, so this is just a different notation. In the last example, we were calling this p sub 1, polynomial of degree 1. This is just saying we're using a Taylor series to find a first degree polynomial. They are also calling that a linear function, which we know it's the same thing. And then also a Taylor quadratic function, t sub 2 of x. We need the following. So first thing that we need to do is we need to figure out what all of those coefficients are. In the coefficient is the derivatives of each one of those. So let's go ahead and find derivatives first. So f of x is equal to 5e to the x plus 4e to the negative x. F prime of x is equal to 5e to the x. Now remember your chain rule on this one. It's all going to stay the same, but we do have to multiply it by a negative 1. So what that's going to do is change our sign here. So minus 4e to the negative x. Then f double prime of x equals 5e to the x. And again, our chain rule is going to change our sign. So bring that negative down. It's going to become positive 4e to the negative x. Okay, so over here now we're going to plug in 0 to each one of these equations. So plugging in 0 here, we would have 5 times 1 plus 4 times 1. So 5 plus 4 equals 9. And then here, plug in 0 again. This time we have a minus sign in the middle. Both of these are going to go to 1. And we will have 5 minus 4, which equals 1. Then here, same thing. Both of those are going to 0, so we'll have 5, or to 1. So we'll have 5 plus 4 is equal to 9. So that's our derivative for each one of those. So now, move up a little bit. Okay, so I just rewrote a little bit. So I have the equations that we got. So f of 0 is equal to 9. F prime of 0 we found was 1. And f double prime of 0 was equal to 9. So now we're going to use this information to find, first of all, a first degree Taylor polynomial. So in a first degree Taylor polynomial, we would need both the 0 degree polynomial, so we would need f of 0 plus f prime of 1, times x. So that would be our first degree polynomial. A second degree polynomial, t sub 2 of x, is going to equal all that we have for t sub 1. Oops, that should be a 0, sorry. Equals 1, but it is f prime of 0 of x, and then plus f double prime of 0 over 2 factorial times x squared. Okay, so we're going to find both of those. So t sub 1 is going to be equal to f of 0, which is 9, plus f prime of 0, which is 1, times x. So 9 plus x will be t sub 1. T sub 2 is going to be what we found for t sub 1, which was 9 plus x, plus f double prime of 0, which we found to be 9, over 2 factorial times x squared. So rewrite that, we would have 9 plus x plus 9 halves x squared. And we could rewrite that as 4.5x if you want to, or just leave it as an improper fraction. Either way is good. Okay, and that's it for example number 1. All right, for example number 2, all they want is the first few coefficients. Now when they ask for these coefficients, they do want you to include the factorials in these coefficients. So we are going to start off finding all of our functions and derivatives. So if we want to go all the way to the coefficient of our 4th degree polynomial, we need to find clear up to the 4th derivative of this function. So our function is equal to x third, then f prime of x is equal to 3x squared, f double prime of x is going to be 6x, and f triple prime of x is equal to 6, and then the 4th derivative is equal to 0. Now let's go ahead and plug in our value. Now this one, we are looking at the Taylor polynomial at -3. So now we're going to go back and we're going to plug in -3. So -3 cubed is going to be equal to 27. Negative 27, and then f of -3 of 3 times -3 squared is going to be a positive 27, and then f of -3 on the next, f prime of -3, double prime, f double prime of -3 is equal to -18, f triple prime of -3 is equal to 6, and f to the 4th of -3. So the 4th derivative of -3 is going to be 0. Okay, now we can go ahead and find our coefficients. So we'll just need -27 for the c sub 0. C sub 1 is going to be positive 27. Now when we get to c sub 2, now we're going to have to start changing things. So we have -18 over 2 factorial, which is equal to -9. Then c sub 3 is going to be 6 over 3 factorial, which is equal to 6 divided by 6, which is 1. And then c sub 4 is going to equal 0, which it would normally be 0 over 4 factorial, which is still going to just be 0.